Hello, Stardust Explorers. Welcome back to Stardust Discovery Channel and with Astro Princess. I'm excited today for us to continue with trying to understand how to answer physics questions, especially for certificate examination. On today's episode, we'll be looking at wave-particle duality. This question is coming from Physics WASSCE past question taken June 2021. And I will read the question as thought. Explain the wave-particle duality of light. That's the first part. Second part, a particle of wavelength 4.2 times 10 to the power minus 11 meters travels with a momentum of 1.6 times 10 to the power minus 53 kilogram meter per second. Determine the value of the Planck's constant h. So in order to answer this question properly, I would encourage you to go back to understand what wave-particle duality is all about. I've left some important links on the description box. Feel free to use those to read up on wave-particle duality. You should also consult your textbooks for this topic. I've summarized what this is all about just for us to answer this question. But I will try to give additional explanation as the case may be as we go further. So the wave-particle duality of light is a concept discovered by de Broglie. He figured out that light can be a particle at the same time it can be wave. And this phenomenon suggests that particles at the microscopic level, which you can also call quantum level, can exhibit both wave-like behavior and particle-like behavior depending on the experimental conditions. So we find a typical example, electrons. We find that electrons can have both particle behaviors and also wave-like behavior. There are so many applications of this in our world today, and these are defied classical explanations, right? So that's for the first part. Now, the second part of the equation requires that we solve for Planck's constant. Now, when you are given an equation, what you do is to think about the relationship that connects the parameters given to you. So here you are given a wavelength parameter and the momentum. So you should think, what equation connects wavelength and momentum? Even if you are not hinted about the topic, just thinking about the equations would land you back to the topic. That is important. Sometimes there could be different topics that connects those parameters. Then reading the equation carefully will help you to know which one is relevant. So back to what we're talking about. The relationship between Planck's constant h and momentum, denoted as P here, is described by the de Broglie wavelength formula, which is given as lambda being your wavelength equal to Planck's constant h over P, which is the momentum, is also mass times velocity of the particle. So if you are able to reach this formula, you've gotten yourself one full mark. Right. You now need to transcribe this equation so that it will read the one you are asked to find. So you are asked to find the Planck's constant. So you want to make the Planck's constant h the subject of the formula. Now, that gives you that h will be equal to momentum times wavelength. That step is so important because if you don't transcribe the formula properly, you can mess up the rest of the equation calculation. So from there, you state your parameters, go through them to make sure that they are in their system international units. If they are not, you need to convert. In this case, everything given to us, they are all in the SI unit. So we can proceed from here. So all you need to do is to plug in to that new formula you formed, and that gives us 6.72 times 10 to the power minus 34 kilogram meter squared per second. Now, this can also be translated to joules second. You can leave your answer as kilogram meter squared per second, but getting it to joules second shows that you know the relationship between joules and the kilogram meter and seconds. Joule is also an SI unit, so, and this is approximately the value of the Planck's constant and the unit as well. Okay, I hope this was helpful. For this question, the part B has 2 marks. So if you get the proper formula correctly and get the answer correctly with your full solution, that's a full 2 marks, while the A part gives you 1 full mark if you give the explanation properly. Okay, there you have it. I would always invite you to subscribe, comment, like, and share this video with all those who you know need it and yourself. And then I will leave you with the words of Susan Gale, that the road to success is rarely a straight line. Embrace the detours, all the cornered roads. They often lead to the most beautiful destinations. All right, see you at the top and in our next video. Bye.